Okay, section 8.4 is where we're going to get into what we call the slope of a line. The slope of the line can tell you just a lot of things about a line. If you may have noticed in all the lines that we've been graphing recently, some of them seem to slope uphill, which is what we call a positive slope. Some of them seem to slope downhill, which is what we call a negative slope. And then we talked about the horizontal ones and then the vertical ones. So we have 4 different kinds of slope, positive and negative, and then we have a 0 and an undefined slope. I like to think about it as skiing, so kind of just to keep them all separate. If you're skiing up, you would have a positive increase in elevation. If you're skiing down, it's a negative increase in elevation, or a negative elevation. A 0 slope, you have a 0 change in your elevation. And if you tried to ski down a hill, you are probably going to be undefined. So, now what the slope exactly is, we're going to use this phrase a lot. The slope is the rise over the run. That is most commonly what you'll hear described slope as. But more specifically, it is the difference in y coordinates over the difference in x coordinates. So it's my change in y over my change in x, which can be the most confusing part about this because most people are tempted to put the x's in the numerator, but we're going to stop that right away. We are going to put our y's in the numerator, our x's in the denominator. It's really just as simple as that. We're just going to be subtracting and then simplifying some fractions. So let's jump into some examples. So I want to find the slope through the given points. So first I have 1, 2, and I have 4, 7. Now there's a couple ways that you can find the slope between 2 given points. One of the ways is to just simply look at your y coordinates and subtract them. So if I'm going to start with this point and go to this point, maybe I take 2 minus 7, and then for my next point, for my denominator, I'm going to subtract my x coordinates. So my x coordinates are 1 and 4, so I'm going to take 1 minus 4. 2 minus 7 gives me negative 5. 1 minus 4 gives me negative 3. Now we can simplify this. We don't want to change it into a mixed number because we want to think about slope as rise over run, and just as a regular fraction even if it is improper. We don't want to change it into a mixed number, but what we can do, if I have a negative over negative, I can simplify that into a positive. Now another way that I've seen is to make a table. So if we list out our x coordinates, I have a 1 and I have a 4, and list out my y coordinates. The 1 was mapped to a 2, the y was mapped to a 7. Kind of the same thing, but we're looking at the difference in y coordinates. There's a difference of 5 there. There's a difference of 3 here. So my difference in y over the difference in my x would be 3. So either way, make a table or just subtract them. I will do both ways for you guys so you can kind of pick which one sticks with you better. Okay, so let's find the slope between negative 2, 5 and 6, 1. Okay, well let's do the table this time. So I have the point negative 2, 5 and 6, 1. So if we look at the y coordinates, the difference between 5 and 1 is 4. Now, this is where you have to be careful because I took 5 minus 1, so I need to take negative 2 minus 6, which hopefully you notice is negative 8. Okay, so if I put the difference in my y over the difference in my x, notice here that I can simplify that. So the slope between these 2 points would be a negative 1/2. Notice that it's negative, which means this line is going to be sloping down, which on the last example, it was a positive number, so it would be sloping up. Okay, for the next one we'll do just looking at the points and subtracting them in a fraction. So 0, 0, 3, negative 9. Okay, so we have an x and a y, we have an x and a y. So if we look at my y coordinates, and I'm going to subtract them. So if I have 0 minus a negative 9, be really careful. I am subtracting and that 9 is already negative, so you do have to have that minus a negative 9. And then I have 0 minus 3. Okay, well, minus a negative, I can change that into a big plus sign. 0 plus 9 gives me 9. 0 minus 3 gives me a negative 3. And 9 over negative 3 gives me a slope of negative 3. So this line would also be sloping down. Okay, I'm going to have you guys try this next one on your own. Find the slope between the points 5, 0 and 7, 8. Alright, so whether you used the table and found the difference in your y-coordinates, or you used the fraction, you should end up with a slope of a positive 4. If not, check your work, see where yours differed from mine. Okay, these next examples are going to be just a little different. Let's find the slope between the points 6, 3 and 6, -1. So if we subtract my y-coordinates, 3 minus a -1, and subtract my x-coordinates, 6 minus 6, minus a negative turns into a big plus. So I get 4 in my numerator, and I get a 0 in my denominator. Now, if you end up with a 0 whenever you subtract your coordinates, one of two things can happen. This is the first one. If I have a 0 in my denominator, I can't do that. Doesn't work. So if you end up with a 0 in your denominator, that is called an undefined slope. So that is the line that would just run straight up and down. So up at the top of your notes, if you want to go ahead and add that an undefined slope, whenever you plug in your numbers, is going to be a number over 0. That might be kind of handy to have. Now what we're going to see on the next example is if it's actually flipped and you end up with 0 over a number, that's just going to be a 0 slope, because I can take 0 divided by a number. It's just going to be 0, but I cannot take a number divided by 0. It just doesn't work. So let's look at this one where I have -7, 4 and 5, 4. So if I take my y-coordinates and I subtract them, and I take my x-coordinates and I subtract them, I end up with 0 over a -12. Notice I have a 0 in my numerator. I can take 0 divided by a number. 0 divided by a -12 is just 0. So my slope would be 0. And this would just be a horizontal line.